Welcome to my lecture online. Let's continue with our physics review. We're talking about torque and static equilibrium. Remember, when nothing is moving, we know that all the force in the x direction, all the force in the y direction, and all the torques must equal to 0. So when we're trying to solve a problem like this, we identify all the forces. Notice we have 1, 2, 3, 4, 5 forces. We're looking for the tension in the string. Don't forget the 2 forces, vertical and horizontal direction at the point of rotation. This beam can rotate about this pin right here. And of course, we need to know how much tension is required to keep the beam from rotating. Just like before, we sum up all the torques, it must equal to 0. So the torque caused by the small mass at the end, the torque caused by the big mass, meaning the mass of the beam acting through the center mass, and the torque caused by the tension. Notice the direction determines the sign. Now, we have D1, D2, D3, that's easy. We simply take the perpendicular distance from the point of rotation to where the force is acting, to the line of action of the force. So when you first plug in the distances, D1, D2, D3, makes it really easier to solve the problem. And then you figure out what each of the distances are. D1 is the full length, D2 is half the length of the beam, and D3 is the length of the beam times the sine of theta. Then you can, of course, get rid of the length because it's the same in every term. Solve that for tension, and you get 2940. Also, if you want to find the forces on the pin in the x and the y direction, you sum up all the forces in the x direction, you sum up all the forces in the y direction, and voila, you get the 2 results if you're also asked to do that. So this is a very typical type of problem that shows you how to find, first of all, the tension in the string to keep it from swinging, and secondly, the forces on the pin where the whole beam is rotating. And that is how it's done.